Okay, let's look at how we're going to solve this problem here. We have the 95% confidence interval for a proportion. P is given by 0.558 is less than or equal to the proportion, which is less than or equal to 0.842. Find A, the sample proportion P, and B, the sample size N. Okay, so very first thing that we need to understand about this, okay, is that this here is our formula for the 95% confidence interval, okay? And we can equate this part here, okay, is equal to this number here. And this part here is equal to this number here as well. It's exactly the same thing. Only here they've got it in calculated form and they haven't given you these values of P and of N, and sometimes we equate this 1 take P to be a Q. So you need to work these out yourself. Okay, so what we have then is 0.55 P take 1.96 times the square root of P Q on N. Now Q is just a fancy way of writing 1 take P. Okay, so instead of writing 1 take P in there, we're just writing Q. Now this is equal to 0.558. Okay, and let's call this equation 1. All right, so we have this is our first equation here. Okay, and our second equation then is going to be P plus 1.96 times the square root of PQ on N is equal to, from the example, 0.842. Okay, and of course we'll call this equation 2. So the very first thing we want to do then is solve for this number P. All right. Now if we notice, what we have here is we have minus 1.96 times the square root of PQN, and here we have plus 1.96 times the square root of PQN. So if we add these two together, they're going to cancel out. So that's exactly what we're going to do. So we're doing equation 1 plus equation 2. So P plus P, this is going to equal 2P. And we have minus 1.96 times the square root of PQN plus 1.96 times the square root of PQN. These cancel each other out. So that's not equal to anything. And we have that's equal to 0.558 plus 0.842. .4. So 2P is equal to 1.4, and this is just an algebraic equation. You can solve P is equal to 0.7. Okay, so we've solved for P. Now we just need to solve for N. So the way we're going to do that is put this value for P into equation 1. Okay, so we're going to put P equals 0.7 into 1. So we have equation 1 here then is, and I'll copy this down so we can maintain our chain of thought. We have P is 0.7, so we've got 0.7, 0.7 take 1.96 times the square root of 0.7 times, now Q, remember Q is just 1 take P, and 1 take 0.7 is just 0.3. And this is divided by N. Now N is what we're trying to solve here. And that, of course, is equal to 0.558. So we're trying to get N by itself here. So basically, we're going to need to do a bit of algebra. Okay, so this 0.7, maybe what we'll do is we'll do the algebra first and then perform the operation. So let's rearrange this formula to get n by itself. Okay, so the very first thing we're going to do is take p from both sides. Okay, so we've got p here, we're going to minus p there, and we're going to put minus p over here. Now the equation is still balanced, okay, only this time we've got rid of that. So now we have minus 1.96 times the square root of p q on n is equal to 0.558 take p. Okay, now let's move this minus 1.96 over. And the way we're going to do that is divide both sides by minus 1.96. Okay, so on this side we have minus 1.96 at the top and the bottom, so that can cancel. Okay, so now we have the square root of pq on n is equal to 0.558 take p divided by minus 1.96, and we want to get rid of the square root, so the way we're going to do that is square both sides. Okay, so we square that, we square that, and this is all just algebra. Hopefully you're pretty familiar with these skills. So we have pq on n is equal to 0.558 take p on minus 1.96 squared. Okay, and now you just need to rearrange to get n by itself. Okay, so n basically times both sides by n and divide both sides by this factor here. So n is going to be equal to, you can either use the rule of reciprocals or rearrange it however you wish. N is equal to pq divided by this factor here, 0.558 take p divided by minus 1.96. And all you need to do is put the values for p and q in there. Okay, remember p equals 0.7, q equals 0.3. So let's put these values into our calculator. So we have 0.7 times 0.3. Perform this operation first. Okay, so we have 0.21, and this is divided by 0.558 take p is 0.7. Now I need to put this factor, this factor squared, let's not forget that. So I might need to put another bracket in there. 0.558 take 0.7. Now I'll close that bracket, and that's divided by minus 1.96. One too many nines. Close the bracket, and that is squared, and I'll close the final bracket. The answer we get is 40. Okay, we need to do 40 samples to get 40 samples were done to obtain this confidence interval with the p-value equal to 0.7. Okay, so that's how we do that one. All right, you just recognize that there are two equations, add them together to solve for p, and then you just need to do some simple algebra or complex algebra to rearrange it and solve for n by itself.